So welcome to the workshop CrowdSec for absolute beginners. There we are. Well, in order to participate in this workshop, you should have some kind of experience with SSH and Linux, and knowing what how at least one editor works in Linux. And you should also have some kind of computer with an SSH client, and preferably also a keyboard, else it's going to be a real pain in the butt. And also, please pay attention and follow along. I really think it's a pain in the butt talking to people that don't seem to respond, so please do that. The whole objective with this workshop is to learn about the CrowdSec architecture and some common use cases. We'll be installing the CrowdSec engine and the Nginx bouncer, as well as the firewall bouncer, but that almost installs by default. We're also setting up reCAPTCHA and testing that it works with the Nginx bouncer. Then we're going to work a little bit with the cscli. One of the things we'll be doing is loading code logs into CrowdSec. Then we'll do some visualizing of the results using Metabase, which is built in, and the CrowdSec console, which is our free-to-use SaaS solution. And in the CrowdSec console, we'll also be looking a little bit of the features of it, and also the CGI lookup, which is one of the more important or interesting features, at least. You should open the slides yourself. There is a URL to the slides because you will need to copy paste a bit during the workshop. After each assignment, I'll wait for everyone to finish before we move on. And if you're bored, I suggest you move ahead at your own pace. And since we aren't that many, just let me know whenever you're finished. And if you have any questions, just send me a DM in the voice channel. I need to find it here. Yes, there it is. All right. If you get logged out from your VPS, either you can log in from an alternate IP and delete the band by using cscli decisions, or ask me to do it because I have a backdoor into each VPS. Don't use your own VPS for this. I've set these up especially for this, and there is some custom stuff that you can't get anywhere else. The first thing we'll be talking about is how CrowdSec works, the architecture of CrowdSec, and also the CrowdSec consensus engine. And this is not a thorough test about what CrowdSec is and how it works, because if you need that, I did a talk in B/London last year, and you can see the recording on the link in the slide set. But first, the first thing you should know about CrowdSec is that it's not just a new version of fail-to-ban, because in reality, CrowdSec is a highly advanced framework for detecting anomalies of any kind. You can do so much more than fail-to-ban, and also protect against way more advanced attacks like Layer 7 DDoS using Cloudflare and Fastly, or even your own Nginx bouncer or Nginx VPS. It can protect you against bot scraping, bot scalping, credit card stuffing, for instance in Magento CMS, data exfiltration from S3 buggers or anywhere else, and much more. Also, as we'll see later, CrowdSec doesn't just block traffic. Other options such as captcha is available, or you don't block anything if that's what you want. Here's a few slides about how CrowdSec works. CrowdSec works by reading logs. So the first thing you do, obviously, is to add logs to CrowdSec. CrowdSec supports syslog, journald, CloudTrail, Kinesis. Those are both AWS log sources, Docker log, an ordinary flat file, and as well as Windows event log. And in a little while, we'll also support Apache Kafka, and more to come probably. After you've added the log, then CrowdSec starts passing the log file, and whenever something turns up in your log file that's a threat, it detects that, hopefully, and the CrowdSec agent will also detect or will also download a block list from the community to begin with, and then Bouncer remediates the threats that it found, and also the threats. It also detects the Bouncer also blocks all IPs in the block list by default. And then what happens after an attack has been blocked on your local servers is that the logs will be shared to us, shared to CrowdSec, and after that, all the signals that we have been collecting will be assessed, removed for all false positive will be removed, and then the rest will be distributed to each agent as block lists. The sharing part, I forgot that the sharing part can be disabled, but please don't, because that sort of destroys the whole idea about the crowd and all that. CrowdSec is what we call API centric. All components can run distributed and communicate using REST API. So what happens on this flow that you can see on the drawing is that data is also added to the left, and then you can see the whole flow through the application where the behavior is detected and signals are pushed back and forth, and the bouncers are querying the CrowdSec agent for signals or for IPs. Yeah, and also CrowdSec can also send notifications if they are or if that is implemented. Of course, that's not a must. CrowdSec nearly runs everywhere. We are Linux geeks, most of all, so it runs on every major Linux distribution, both ARM and x64. It runs on OpenWRT, on Synology, and much more. Even Arch, but that's a community contribution, but still. CrowdSec also runs on Windows. It's a rather basic implementation in the sense that we don't support so much in Microsoft land as we do in Linux land. For instance, we don't support the hooking into C# applications as we do with Python and JavaScript application or Python or PHP. CrowdSec also runs on FreeBSD and OpenSense, and finally, CrowdSec also runs on Docker in Kubernetes and also in Kubernetes using Helm charts. In terms of bouncing, the IPS part of CrowdSec can bounce on provider level. We support hooking into AWS WAF, into Cloudflare CDN, or Fastly, which is also a CDN. CrowdSec can also bounce on network level, of course, on the host firewalls, as you probably know, IP tables, NF tables, PF, or Windows. We also work on being able to block on BDP router level. We are working with providers of BDP block lists so that we can block the bad guys directly on BDP level, meaning that BDP is the protocol that all ISPs communicate with. So that means that we can actually route the IPs on a very basic level in the internet. On the internet, which is more or less the whole vision of CrowdSec, to detect attacks by the bad guys right away and block them right away, so that the end game is that we'll make it more or less impossible for them to do whatever they do, and this is an important step in that direction. CrowdSec can also bounce on server level. On this drawing, we have Nginx, Traffic, Caddy, and HA proxy, but there's a lot more. There are many more bounces going on in that sense. You can see them all on the hub, which we will be looking at later. And then, as I briefly mentioned before, CrowdSec can also hook into PHP application, Python application, into Go application, or into JavaScript applications. CrowdSec can also run serverless, mostly on AWS, because AWS is what we use for our own infrastructure. So CrowdSec can read Kinesis and CloudTrail logs, run on Kubernetes on AWS, and then also bounds on AWS WAF. And obviously the WAF can be put in front of everything run every web-based service basically. And Windows, as I said, it's not that advanced, but it does understand all the data sources as it does on on other platforms, minus Journal D, which is Linux only. It can pass Windows event logs, Windows out logs, Embassy as well out logs, Windows firewall logs, and IIS logs if they are in W3C format. In terms of scenarios, they can detect the brute force of remote desktop, SMB, MS SQL, Exchange, basically everything that's in the Windows Windows authentication logs. CrowdSec can also detect port scans on Windows as it can on Linux, although it's a bit simple because Microsoft's firewall doesn't log port scanning unless it happens on a port that is already open, or unless which is not what happens on IP tables or on any other Linux or Unix firewalls. There, everything is being logged. So it's not very interesting to log or to try to log port scans because you won't get much out of it. But the possibility is there. And on Windows, we only bounce on the Windows firewall. One of the first things that people tend to ask us about with all this crowd stuff is how we deal with poisoning and false positives. And the way it works is that every CrowdSec agent has a trust rank associated. The trust rank starts with 0 once they start sending signals to us, and then over time, as they are sending reliable and trustworthy signals, they will increase. And after 6 months of being totally reliable, they will have a trust rank of 99. And that trust rank is relevant whenever the consensus engine is trying to find out whether an IP is bad or not. Because what happens, automated of course, and much faster, is that the consensus engine looks at all the IPs in the signals database, and it asks each agent of each IP. And if the agent knows it, then it will vote with the trust rank it has. And an IP needs to have a certain threshold of points or votes in order to be selected as bad. So this means, in reality, that if you want to have any influence in the voting process, you need a relatively high trust rank, and that takes time. And on top of that, every ASN only has one vote. So not only would you have to wait a long time if you're a bad guy trying to poison the database, you will also need to have your agents running on different ASNs all across the world. All of this is supposed to make it cumbersome and expensive to poison the database, because we are not naive. We know that it is possible, but the only thing we can do is to make it as hard as possible, and that's what we have done. In terms of false positives, we are running our own little fleet of honeypots. They have a slightly higher trust rank, and we use them to double check or verify community signals. Then we have a block list. The way it works is that there are certain IPs that you can't block. For instance, Google SEO bots or Cloudflare CDN or Google DNS, Cloudflare DNS, whatever. Because things stop working if you block stuff like that. So that's not possible. And secondly, we have a predictive algorithm that tries to fast-track bad IPs to the file database based on their environment or characteristics. Whether they have dangerous service exposed, then we assume that there is a bigger risk of it being compromised and thus being bad. Once the entire process has been made has been done by the consensus engine, then the IP will be deemed bad if it is bad, of course, and then it's being thrown into the FHIR database. The first one is called a smoke database. Then the consensus engine looks at all the IPs and throws everything that's bad into the FHIR database, and then they are being distributed to the agents as block lists after this. This is a very simplistic overview just to say that when the bouncer is trying to figure out whether an IP is bad or not, it asks the agent, not the other way around. Yeah, it took me a while to understand that. That's why I have a drawing just for that. In terms of observability, there are a number of various ways to get insight into your CrowdSec agent. You can use Grafana based on a local Prometheus, because the CrowdSec agent also spins up a Prometheus, local Prometheus, that you can use for that. We won't be covering that today though. Instead, we'll be talking about the cscli, which is actually also using the Prometheus, but you don't know that. You just type the cscli command and then you get data out of it. Metabase, that's an open source graphing system that CrowdSec supports. The way it works is that CrowdSec will download a Metabase Docker container and spin it up in the background, and we'll be doing that. And then thirdly, we'll be looking at the CrowdSec web console. I also talked about that a little bit about that in the beginning. Important files you should know is the acquisition YAML file. This is where you define all data source and types. The etc CrowdSec bouncers directory. This is where the config files for all your bouncers are available. Then there's the profiles YAML file. This is the config for deciding which attacks triggers which remediation and how long. We'll be looking at that in a little while, where we will be configuring the Nginx bouncer to do recaptcha and stuff like that. We're doing that in the profiles YAML and in the bouncer config, of course. In the profiles YAML, we'll decide which that web-based attacks are being handled by the bouncer, by the Nginx bouncer, and all other attacks are being handled by the firewall bouncer. But that will come later. In terms of log file, there is the log files as a bar log CrowdSec log file. This is the agent's log file, and it's human readable, so it's actually relatively easy to understand what's going on in it. And there's also a bouncer log file for each bouncer. This is the last boring slides before we start doing anything, so bear with me, please. This is the CrowdSec taxonomy. The slides about which term covers what. Signals, those are the local information on a given attack that is being sent to CrowdSec and put in the smoke database. The LAPI is a local API. It's used to control the various elements of your local CrowdSec stack. Then there's the CAPI, which is the central API. It's used to get block lists from the community, and also this is where the local agent sends signals to the smoke database using the CAPI. The agent does all the passing of logs, controlling bouncers, and communicate with CAPI. It's possible to have more agents if you have a very distributed environment, so you can spread the log passing to several agents if you want that. Bouncers, they're the IPS part of CrowdSec. They mitigate risk by blocking malicious traffic, because as we'll be seeing later, blocking is what happens in a firewall, and that's not necessarily what happens. We can also force users to go through a captcha, which we'll be doing later in the workshop. Parsers, those are text files written in YAML and Grok that tells CrowdSec how to parse a given log file. Scenario is a YAML file that describes the attack we want to react upon. One example of this is a brute force scenario. In that YAML file is defined how many attacks in how much time it's allowed to do before an attack will trigger. Oh, sorry, a block will trigger. A collection is a collection of parsers and/or scenarios for one system or use case. For instance, we have a collection called HTTP-CV, which is basically just scenarios that describes common web attacks. So if you want to use your CrowdSec system and your web server as a sort of honeypot on attacks, install that collection, and we'll be doing that later, so you know how it works. Post overflow is the action that's being executed when a given scenario has been triggered. For instance, DOIP is a post overflow thing. Whenever a scenario has been triggered, we want to look at the IP that has been attacking us and doing some basic lookup over it, like which ASN does it belong to, which country does it belong to, etc. Decision, this is what is generated when a scenario is triggered. And alert, this is what a decision are turned into. They are transformed into alerts based on local preferences in the profile YAML file. By default, there is a 4-hour ban on each IP that triggers a scenario. All right. In order to log into your servers, you need IPs, and they are available at the at bit.ly//crowdsec-IP. Of course, in order to install, you will need something with an SSH client. And please send me a DM, and then I will give you a number, like what number of IPs should you log into. When you are logging into it, or each of you has 2 VPSs. One is the defender, and one of is the attacker. And on both, the username is workshop, and the password is loudgoose90. And when you log onto it, use the default password. What will happen is that you will be forced to change the password on the first login. Once you have changed it, you will be disconnected, and then you will need to log in with your new password. And once you have your IPs, please log into both VPSs to verify that they work, and you'll be installing CrowdSec on the Defender VPS. So as I said, please send me a DM so that you can get the IPs. If you go into the list of IPs, you can take IP number 1 or the line number 1. And please verify that you can log into both. But once you have logged into your VPSs, please give me a heads up so that I can continue. But as I said, please make sure that when you are trying to install things, you will do it on Defender. That's a Debian VPS, whereas the attacker is a CLI. And CLI is not supported as an install platform because it doesn't really make sense to install a CrowdSec on Kali Linux anyway. Not in a typical use case, that is. Right. Once you have installed, or once you have logged into the Defender and you're ready to install, you should be adding. You will first need to add the CrowdSec repository to your server. In general, of course, don't install software on production system like this, meaning downloading a random script off the internet and execute it with root permissions. That's usually not a brilliant idea, or it could be. It's just pretty risky. But the reason why we do it is basically because of convenience. Once you've added the repo, first you install the CrowdSec agent, which is just called CrowdSec, and then you'll be installing the bouncer, IP tables, and the Nginx bouncer. There's both an IP tables and an NF table based firewall bouncer. It doesn't really matter which one you're using if you don't have any firewall to begin with. Then IP table is fine, so that's what we do. If you do have another firewall, please install whatever that is, because you have if you have an NF table based firewalls, you should try the NF tables bouncer. Yeah, first install the agent and then install the bouncers. Don't try to install it all in one line, because you can control the order of installation, and you would want to install the agent first, so that the bouncers will be auto added to the agent. When you're installing the agent, you will see what we could call semi-disturbing quotation errors, because it isn't really errors. They look a little bit boring, but it's only just warning, so no worries. The lines I have marked is the CrowdSec install visit. When it installs, it tries to figure out which system it's running on and which services are running. And in this case, it has found out that we're running on Linux, and that there's an Nginx server installed, and an SSH server. And detecting them also means that CrowdSec will support them out of the box, meaning that SSH logs and Nginx logs are added to the acquisition YAML file, and the public collections and all that stuff is being installed. So you don't have to do that. Yes, install the agent with that command, but that command is actually two commands. The first line, the curl line, adds the repo, and once the repo has been added, you install the CrowdSec agent, and after that, the CrowdSec bouncers. Yeah. And once the agent is installed, please, or you have installed the agent bouncer, please let me know.
Yeah,
No.
I'm installed.
All right, great.
Should I go through the update stuff, like, or just wait?
But do you mean if you have to install or you have to run an apt-get update, or what are we talking about?
Oh, I just read ahead to slide 27. I'll just wait then.
Yeah, I can't remember what's on that side. But just to answer Kirito, though, you don't have to restart the agent between installed the agent and the bouncer.
Okay.
The only time you have to restart anything I have written, you should restart things. If I haven't written it, then you shouldn't.
Okay, cool. Thanks.
The first thing you probably want to do after installing the agent is to install best completion, and you do that by running the two commands here. First, making the cscli generate the script you need, the best completion script, and then starting another instance of bash so that it's also enabled. And you test it out by typing sudo cscli and pressing the tab button twice, and then you will see the options that you can use with the cscli. And while you're fiddling with that, I'll tell you a little bit about the CrowdSec hub. Because the CrowdSec hub is a central repository for parsers, collection, and bouncers. You can compare it to Ansible Galaxy or Docker Hub. Community contributions are also added if the author wishes so. And when you are engaging with parsers and scenarios or collections with the cscli, then what happens is in fact that it contacts the hub and downloads everything directly from there. Also, the CrowdSec hub is on GitHub. So the way it works, if you have contributed anything to the CrowdSec hub, is basically that you're doing a PR, a pull request on the hub repository, and then we add it, and you're on the hub. That's basically how it works. Pretty simple. And the way it works with collections and everything you download from the hub is that it's not installed by default. It's not being upgraded by default. So if you want to install new updates, new additions to collections, stuff like that, you need to first run the sudo cscli hub update and then an hub upgrade afterwards. And the easy way to automate that, of course, is to create a cron job that updates this like once a day or something like that. And if you automate that, make sure to also automate a reload of the CrowdSec agent, or your new collections won't be, or your new parsers or collections or scenarios, they won't be used by the agent. So that's a small detail. In terms of managing collections, I'm using collection as an example, but the same thing goes for scenarios, parsers, or post overflows or whatever. First, you type sudo cscli collection list to get a list of the collections. If you add a -a, then it will list all the collections that's available via the hub. You can also choose to install a collection, install, and then the collection name, upgrade, collection, and a name. The same thing. There's also a remove command, works in the same way. And if you want to upgrade everything, upgrade all collections at least, then you do collections upgrade -a. This is the way all the commands are being built. If you want to do a manual ban for testing, for instance, then you do it using decisions, add and --IP and then the IP. If you want to unban somebody, for instance yourself, then you do it by first typing sudo cscli decision list, and then delete the number on the list that you get from the list above. Sudo cscli decisions delete. There should be a sudo in front of it. I'm sorry, I forgot that, but you will find out pretty soon because you can run the command without. Then do a sudo cscli metrics to get an overview of what's going on and how many lines the agent has parsed and how many bands are active and stuff like that. In order to make sure all this Nginx bouncer stuff works, we need the Nginx bouncer. We need the Nginx collection. And if CrowdSec probably also discovered your Nginx, then the collection is also installed. But to make sure that it's there, please do a sudo cscli collection list. And if it's not installed, please install it using the command that I put on the slides. And also, we also want the HTTP/CV collection. I think it's installed by default, but if not, feel free to install it. In that way, your web server will become some sort of a honeypot that will detect log4j and all sorts of things as well. Whatever attacks we have in the HTTP/CV collection. And while you're fiddling with that, I want to talk a little bit about the pwn spoof tool, which is made by our friends in Punk Security. It emulates attacks in a log file, or to put it another way, pwn spoof generate fake log files that looks real. We are using it to create an Nginx log to ingest in CrowdSec in a little while, and it works pretty well for that. So if you're ready for it, you should try and import the pwn spoof log file to CrowdSec. And please let me know if I'm moving too fast. Yeah. I should probably look at the log. The chat log. Yes. All right. Sudo CrowdSec DSN file the path to the file type Nginx. That's because it's an Nginx log. Also use the no API command, because we are effectively spinning up a separate instance of CrowdSec, and that will parse a log file as if it was in a live situation, and then put them into the same database as the other instance of CrowdSec is running or is putting them into. All right, good. So if you're both working ahead, that's fine, no problem. The replay mode is a great feature if you want to have an idea of what CrowdSec could have done in your environment at a certain time or situation, or if you want to investigate O-log to see if hackers tried to abuse a vulnerability before it was made public. For instance, like with Log4j. When you are running the pwn spoof, or when you're running the replay thing and it ingests the pwn spoof log, then you'll see a number of lines like these. You won't, of course, see the same thing because pwn spoof will randomly generate, randomly insert IPs and stuff into the log files, and attacks also randomly. But it will look something like this, and each line is an attack that's been detected by CrowdSec as if it had been a real life situation. In terms of configuring Nginx and the bouncer, the workflow is this. First, we'll set up Google reCAPTCHA on Google servers. and then we'll configure the Nginx bouncer to use those keys that you get from the recap setup at Google. Then you will check that HTTP you will check that HTTP scenarios are installed. That's a collection. In terms of Google reCAPTCHA, I do have a set of keys that you can use that I've generated. So no problem. I'll just paste them to you. And that also goes if you are watching the recording and you don't have a Google account, please let me know. Then I can give you the keys, the side keys and the secret keys that you need to configure the bouncer. After you've checked that the HTTP scenarios are installed, you need to verify the configuration of acquisition YAML file to make sure that all the right logins are there, so everything works. After that, we'll configure profile YAML file to make sure that the right mitigation is for the right attacks. As I said in the beginning, we'll configure it so that all web-based attacks are being handled by the Nginx bouncer, and all other attacks are being handled by the firewall bouncer. And we'll be doing that in the profiles YAML file. And then afterwards, we'll verify that everything works using Nikto and the SSH brute forces to also try both the Nginx bouncer and the firewall bouncer. Hang on a second, and I'll find you those reCAPTCHA keys. Right. The first thing we'll do is to log into google.com/reCAPTCHA/admin/create, and then configure the reCAPTCHA like this. You will need to choose reCAPTCHA version 2 because unfortunately we don't support the new version 3. Then the way I do it is that I'm selecting the I'm not a user, sorry, I'm not a robot checkbox. Then you need to add the CrowdSec workshop.xyz domain and accept reCAPTCHA terms of service and press submit, and basically that's it. Then you will get something looking like this with a side key and a secret key. And make sure to note both of them because you'll need them on the next slide. This is where we will be installing or be configuring the Nginx bouncer. You'll be editing three things in the configuration file, and two of them, well, that's a secret and a side key that you just got from Google. And you will also need to change the mode equal live line to mode equal stream. Basically, it's a performance thing. How often is the bouncer updated with new IPs? With live, it's being updated real time, and that works if you have a very small setup that's not very busy. But once you are on a busy server, it takes up a lot of resources, and you probably don't want to do that. So change it to mode equal stream. Then it gets updated every 20 seconds or something like that. And after that, restart Nginx. In order to verify that everything works in acquisition YAML file, we need to verify that the Nginx logs are added. As I said before, if the CrowdSec wizard has detected Nginx, then the file names are added to the acquisition YAML file automatically, and there's nothing to worry about in that regard. You don't have to if you're looking into the acquisition YAML file, then you will see that the wizard hasn't done it the way I've done it. I've done it the lazy way by adding *log. So the CrowdSec parses all log files, whereas the way the wizard does it is that it adds two entries, one for the access log file and one for the error log file. But in practice, it doesn't mean anything. So you can use either. Profile YAMLs. The profiles YAML file is the file that determines what happens when a given scenario is triggered. You can either, for instance, increase or decrease decision duration. Default is 4 hours. You can decide the type of remediation that should be applied. By default, it's ban. It can also be captcha. You can also decide the scope of the remediation. By default, that's IP. It's IP because CrowdSec is a very flexible framework that can detect deviation is in practically anything. It very much just depends on the data source that you have written, and we have chosen to use CrowdSec mostly for IP and for security. So it makes sense that default is IP. You can also enable or disable debug for a specific profile. And the default profile YAML file looks like this. It takes all remediation, all scenarios where remediation is set to true, because the way it works with scenarios is that they don't necessarily need to do anything. It could just be a scenario that detects something, but you can't really do anything about it. You just want to know that this attack is in my log. So where remediation is true and where we're talking about an IP, then it will ban for 4 hours by default. The new configuration, the way it will be structured is that the new captcha remediation will be put in first, and then all scenarios start with cross security /HTTP will be forced. Well, we will mitigate them by force users through captcha for 4 hours. Everything else goes through the default IP remediation, ban users for 4 hours. So this is when you open the profile YAML file, you should add everything that's marked in green and put it in front of the red one. The red thing is the lines that's being marked in red. Those are the lines that are already there. So the file should look like this. Yeah, whatever you have in your file is correct. You don't need to add what I've written. What I've written on the slide is for you to add manually if there's nothing there. So either you do the lazy way I've done it, we're using *log, or as the wizard has done it by writing access log and error log. And if those two lines are in your acquisition YAML file, then everything works. So no problem. And also remember, this is a YAML file. So this means that if you get weird errors, then some spaces in the file are wrong, or you only put 2 dashes to separate the two parts of the file. You also get a very, very weird error if you do that. I've tried that. I had no idea what it meant. So as I said, if you get a weird error, assume that something is wrong with a space somewhere, because it's YAML and it's a pretty difficult to work with in that sense. It's pretty sensitive. Once you've modified the acquisition YAML file, then reload CrowdSec. So now comes the fun part. The first thing you're doing is to log into the Defender VPS and watch the CrowdSec log, basically tailing it. If you use tail -f, then it will automatically read or show you new lines in the log file on the screen. So that's the first thing you do. The next thing you do is to log into your attacker VPS. So you will do both attacks from there. Then first you will do an SSH brute force, and then you will verify that the log is being or that the CrowdSec detects the attacks because the log will show you, and that it bans. And then afterwards we'll try an SSH to the Defender VPS from the Kali Linux to make sure to verify that you should be banned, because the firewall, the CrowdSec, the bouncer the firewall bouncer has blocked you in the firewall, so you can't even connect to it. Then afterwards you run a web scanning using Nikto. Nikto is an old web scanning tool that's really noisy, so it's almost impossible for CrowdSec not to detect attacks with it. That's why we use it. It's pretty good for that. Similar, you will see attacks. You will see log entries in the CrowdSec log, where it will tell you that it has detected attacks and that it has blocked you again, or blocked the same IP again, and also that it has done it using the captcha. Yeah. So it says so. It also says that in the log line here. And once you have done the Nikto attack, please let me know, because then we are going to verify, and we'll be doing that in a little bit advanced way, so to speak, that requires you to really understand what's going on. But I'll be happy to explain it. The way it works when we're going to test the captcha thing is that unlike the SSH brute force, where we will block you in the IP, or sorry, block unlike with the SSH brute force attacks, where you will be blocked in the firewall, then you can't really check it the same way. So instead, we will need to create an SSH tunnel, so it looks like your like the traffic, so it looks like your web connection is coming, or is coming from the attacker VPS. And come to think of it, it actually won't work, because your IP from the Kali Linux is being deleted, or is being blocked by the firewall bouncer. So the first thing that it will do before you try and run the SSH tunnel, and where you're verifying the bouncer, you need to log into the attacker, and then you'll need to delete the decisions. When I went through the cscli, I told you how to do that. Yeah. So basically, the first thing you do to delete the decision is to type sudo cscli decision list, and then you will get a list of decisions that CrowdSec has done, and you will see your own you will see the IP of the attacker somewhere. There are probably more than just your attack because you're on the internet and things get attacked all the time. And once you have located the ID number of that decision, you simply delete it, and then you're able to connect with via the attacker and the web browser, as I told you here. Yeah. I hope that makes sense. If not, please let me know. The way it works with the SSH tunnel is that when we initiate the SSH tunnel, it will listen on port 8080 on the Kali Linux, and every connection that comes into port 8080 will be forwarded to the defender on port 80. So we're doing this using an SSH connection that's initiated locally. So we're connecting from the Kali to the Kali, but as we do it, we're also spinning up an SSH tunnel. So and the way I've set the Kali Linux up is that there are already hosted there are already SSH certificates, so that when you SSH to localhost on Kali, then it will just log in using certificates. So basically, you type that line there and type enter, and then you will get a new prompt, and you won't get an error. And that you don't get an error means that it works. So once you've done that, open a browser on your computer, the computer that you're at, and then go into HTTP attacker, the attacker number that you have. Of course, not exec, but the correct number that you have. .crowdsecworkshop.xyz:8080. Then you will be forwarded, at least in theory, from the attacker port 8080 to the defender, and you should see this "I'm not a robot" captcha Google thing. It was a little bit maybe complicated, at least to explain. But if you have any problems or there is something you don't understand, please let me know, and I'll be happy to explain it again. A question, if we can talk or explain a little bit about Nextcloud protected by CrowdSec. I haven't tried doing it myself, but I do know that there are a number of ways to do it. But the most easy way, I guess, is to install CrowdSec agent on your Nextcloud server and make it pass Nextcloud lock. There is a Nextcloud collection that can pass that make CrowdSec able to parse CrowdSec lock and detect brute force attacks on your Nextcloud instance. And then it basically works just like the SSH, the brute force attack we did. That CrowdSec will detect brute force in the Nextcloud lock, and then block that IP in the firewall with IP tables, just like on SSH. And that's all there is to it. If you want to do it more advanced, you can also set up a reverse proxy in front of your Nextcloud, and then protect that with CrowdSec. But that's really up to you. The simple way is just to install the CrowdSec collection or the Nextcloud collection on your CrowdSec. But yeah, I assume that everybody's SSH connection works and you're able to see the reCAPTCHA thing. If not, then let me know. In terms of observability, we'll first try Metabase, and the way it works is that you'll download the Metabase Docker container using the cscli dashboard command like that. Please, when you run it, make sure to run -l0000 because else it will only be listening on localhost on the server and you can't connect to it. So yeah, do that, and it will take a couple of minutes. It's possible that you're getting an error that says that there's not enough memory on the Docker or on the VPS. It'll probably work anyway, so don't worry. After the install, pay attention to the credentials that's being supplied after starting the dashboard, because those are the ones that you'll use to log into the dashboard to check it out yourself. Those are randomly generated, so I can't help you if you lose them. And if you have any problems or it doesn't work or anything, just let me know. There's a question if whether it's possible to customize the self-host database, the Metabase. That's what we're talking about. Yeah. Well, the way it, yeah, I would say yes and no, because the way we are running with the cscli, then you can't do it, but it's possible to have your own installation of Metabase and use that instead. And there is a if you go to docs.crowdsec.net, then there is some docs on how to make it run with your own instance of Metabase. The title of the article is a little bit wrong or misleading in the sense, because it tells you how to configure Metabase dashboard without Docker. But basically, you can also run it. It also works if you're running a dashboard or running running Metabase in a separate Docker container outside of the cscli. So and if you do that, then you can customize it as much as you want to. So whenever you are ready with Metabase, you should open the Defender IP in your browser, http://defenderip:3000 in your browser, and then log in with the credential that was printed on the screen. Then you will log in, and once you've logged in, you should click the CS main dashboard for an overview of the attacks that you've had, and feel free to click around in it for a few minutes. In the meantime, you should add a user at at app.crowdsec.net because you will be needing it in a little while when we are adding the CrowdSec instances to that. And again, please let me know whenever your Metabase has installed and everything works. So whenever you're ready with Metabase and that works, and you've added a user on the CrowdSec console, then go into the web interface and click Add Instance. Then you will get the enroll line or the enroll code that you need to run or execute in your CrowdSec agent to enroll that instance to the console. So once you've done that, you will accept the pop-up in the console, and then alerts will sync. But of course, Metabase needs to be finished first. there seems to be some problem with Metabase, so we'll just wait for that. All right. But yeah, once the Docker is ready, then or the Metabase Docker container is ready, then feel free to click around in it for a little while, and then move forward with adding the CrowdSec instance to the CrowdSec console. The way it works is that you are clicking the once you've logged into the CrowdSec console, you should click the Add Instance button, and then you'll get the enroll string that you should execute in your CrowdSec agent. And once you do that, you'll get a pop-up in the console, and the alerts will sync. It will look something like this. This is the pop-up that you're getting, and then accept, and then just wait for a little bit. By default, the imported logs will be shown. In the meantime, I thought I wanted to show you the way, show you how my own login of the console works, or how it looks. as you can see, I have a couple of instances installed. I have one running on Debian. I have one running on FreeBSD. Yeah, I even have one running on Windows. I have one running that's running on Raspberry Pi, and two running on OpenSense as well, and then I have one that's running on a VPS along with Nginx Proxy Manager. Yep. Those are just installs that I have on my computer or on my organization, because the way it works with CrowdSec is that you can choose to be part of an organization and then also have some shares instances with the organization. And I'm part of the Alpacas crew, and if I share to that or if I switch to that, if it works, oh yeah, there it is. Then there's a bunch of honeypots that I can see, where I can see the alerts on. But if we're going back to my own instances, then we can see, if I go to the alerts, then we can see, or we can get an overview of the alerts that's happening on my instances. I think it's most interesting to go to the scenarios and see which kind of attacks are happening on my servers. Not surprisingly, what there's most of is SSH brute force, both slow brute force and brute force in general. You can see that here there's a graphical overview. It's basically everything that's happening. Endless SSH BF is my Raspberry Pi that has an SSH tar pit installed, because I think that's much more fun. There is a relatively new feature here called noise cancelling, which is basically just, it will remove everything that we think is background noise and not target attack, and nothing that should affect you anyway. And if you remove that, then things may look a little bit different. For instance, most of the around half of the SSH brute force attacks was removed. Also my tar pit, unfortunately. But that's not all you can see. You can also see which IPs are attacking you, where they're from, or which ASN they're from, and also which country they're from, and a lot of other things. The CTI feature that I said in the beginning that I would show you, there are two ways to get to that. The easiest way is to click on one of the IPs that's attacking you, and then select watch this IP in the CrowdSec CTI. Then you will see everything that the crowd knows about that IP. It's very common that this it's very normal that IPs are relatively new in the database. So we saw this one for the first time on when today, I think. Yeah, it just appeared in our database today, and it's very aggressive still. We know it for SSH brute forcing. Yeah, and it's somewhere on GCP, Google Cloud. That was one way to see it. Another way is to click. Oh, there's a search thing somewhere, right? Probably not. Oh yeah, if you go to the CrowdSec threat intelligence, then you can just write a random IP and see what the CrowdSec crowd knows about that. But what's interesting is that if we go to the other organization that I'm part of, where it's all the honeypots, and you look at the alerts that I see, or that is shown, that these CrowdSec instances see, it's a very different view. If you go to the scenarios like before, you will see that there is honestly a shitload of attacks on SIP, on voice over IP, like the identically IPs, the identical number of IPs or of attacks on those compared to the other ones. Here only 2 and 6% are, or only 2% are SSH brute force, 2-3%. So compared to that, there's a lot of on OpenShips. If I enable noise cancelling, we can see how it looks. There is still an awful lot of voice over IP of SIP attacks. For some reason, there is okay. Oh yeah, those are targeted machines. That one is called localhost. That is a common name, right? All right. Anyway, that was it. I hope that gave you a sort of an idea of what you can use the CrowdSec console for. Oh yeah, another new thing is also the ability to generate API keys. Here we are. Where you can access the CGI using an API. You can create an API key for that. I'm not sure it's part of the free plan, but it's available. So if you have a MISP or the Hive or anything like that, or OpenCGI, then you can access it using that, or access our CGI using that. Anyway, back to the slides. We're almost finished. What now? Yeah, well, you should remember that CrowdSec is not just a fail to ban clone. Here's some inspiration to what you can protect with CrowdSec. You can protect any website behind a reverse proxy, that's Nginx, HA proxy, or traffic. You can also protect your Nextcloud instance, which we talked about earlier, because everybody loves Nextcloud, so it's a good example. You can also use CrowdSec to protect your WordPress sites, or you can use CrowdSec to protect your LAN by setting up a sort of canary device that reacts on port scans or DNS, dookups, and bonjour and stuff like that. Basically, in case anyone port scans your CrowdSec server or your CrowdSec canary device, then you will get a notification, because on your local network nobody should do a port scan. That's the whole idea. FreeNAS is currently is FreeNAS and TrueNAS, is that the same, or is FreeNAS the old name for TrueNAS? I can't remember. I think it's the old name. Yeah, it is. But TrueNAS is a little bit complex in the sense that some of it is based on FreeBSD and using jails, and I think some of it is maybe based on Debian. I don't really know, but I know somebody has been working a little bit with it, but I don't know what you mean. But do you mean in terms of protecting the FreeNAS login like Nextcloud, or what? I don't know if anyone has done that, but I guess it's theoretically possible, at least, if we can get to the log, and if it's possible to install CrowdSec somewhere, then yeah. But I believe that the main OS on the TrueNAS has been locked down, so I'm not sure that you can install anything on it. But yeah, all right, cool. But let me know whatever you find out. And if you want to have a little more fun, then I've installed a Dame vulnerable web application Docker running on your VPS. Except that we just killed it on one of yours, but if you want to try it out, feel free to try one of the other VPSs, or of course download this one again. I can do that if you want that. DVWA is running on a Docker container on port 5000 on the Defender VS, and it's based on Apache. And it's possible using the Docker data source to get logs from it fed to CrowdSec, and then you can use it just like we did with Nikto on the Nginx. Test it to see if CrowdSec can detect attacks using it. It's pretty easy if you know how to do it. You need to add the Docker log into the acquisition YAML, the YAML file, and you can go to the documentation to see how that looks. And yeah, it's a little fun experiment. But yeah, please get in touch. You are trying out CrowdSec, that's cool. That's good. You're also on a Discord. That's also good. But if you have any questions, ping me there or send me an email. And I'll stop the recording now.